Please welcome Kaspars Mickevics, Senior Engineering Manager at Skype.
Hi. So I'm Kaspars. I'm from Skype Service Engineering. And today I'm going to talk a little bit about running Linux on Azure IaaS. But first, a little bit about me, our organization, and our relationship with Linux. So I'm from core services team in Skype. And we, as the name implies, run the core services of Skype. These are backend services, mostly written in C++, running on Debian Linux. And as of 3 years ago, we do that on Azure IaaS as well. Our role as service engineering is constantly evolving. I'd say that we are in a flux constantly. So we used to be a sort of like operations team. We evolved into service engineering, and now we are sort of moving towards being site reliability engineers. So that's like a lot of learning all the time, a lot of improvements to ourselves and to our services. Now, Skype and Linux, well, it's been going on for over a decade now. So Skype's been built on Linux, Skype's been always running on Linux, and Skype is still running on Linux, even though we are part of Microsoft. Once we got acquired by Microsoft, technology stack didn't really change. In fact, we actually expanded into Microsoft's data centers, and we are still running Linux there as well. So currently, though, Skype consists of, let's say, hundreds of services. Some of them are microservices, some of them are like different types of services, like proprietary services. And it's sort of a split between Azure PaaS and Linux. And if it's Linux, then it's either on Azure IaaS or in Skype data centers or in Microsoft's data center locations across the world. So what this talk will be about? Well, I'll hopefully tell an interesting story about how we moved one of our first Linux-based services to Azure IaaS, and some of the lessons learned, as well as some of the practices that we've adopted since then. So, and this story is about relays. So there are different kinds of relays in Skype, used for video calls or audio calls, or some are used for relaying some other types of messages. But this is a story about relays used for calling. Why are relays so important? Well, imagine if you have a bad internet connectivity and you are trying to call someone, then if there's a relay, you can actually relay your call over that, and the chances of you getting decent sound quality increases. So from perspective of like application, relays are just C++ applications running on Debian Linux, written by very, very clever guys in media team in Skype, and ran by the best service engineering team in Skype as well. So their workload on the relays is mostly bandwidth and CPU intensive, and this is important when we go to the load testing of them. Now, why did we choose to run relays in Azure IaaS? Well, there are several reasons. The most important one was that back in the day, in 2015, the capacity for relays was not enough, and the demand was growing quite rapidly. So our relays have been running on bare metal servers for a while now, back then. So we had a choice. Should we buy more metal, deploy it to data centers, or should we perhaps try something else? And at that time, we already had several engineering teams using Azure PaaS. So we thought, well, why not to try Azure IaaS then? So that's what we sort of did. And like this is the story about that. We had some concerns in the beginning. So to understand us means that we were running these Linux servers on bare metal machines for years, for over a decade. So we were used to controlling the whole stack, the network, the server, everything else related to that. And so for us, the biggest concern was how will the relays work on a virtual machine? Because obviously, that's pretty different from running it on a server. So it didn't really have much to do with Azure as such, but mostly just running on a VM was a really big concern. Like, how many such VMs will we need? How will it scale? We are used to tuning the machines to perfection for maximum performance. So how will that work out? That was an interesting concern that we had. Now, one-to-one NAT is an important sort of concern here as well. Because again, since we're used to running our machines on bare metal, we're also used to having direct connectivity to internet. And in Azure, this is not really possible. You have to go through the one-to-one NAT. So that was a concern. Stability, that's an important one, because there are two aspects to stability in our view. One is that how stable are the machines in terms of like, will they reboot or not? Like, what will be the stability like that? And another concern, the stability of performance. just because today it works well doesn't mean that tomorrow it's going to work well. So that was kind of what we were worrying about a little bit. Now, manageability. Well, if you have been managing machines on a scale of hundreds or maybe up to 1,000, that's one thing. But once you start moving to virtual machines, well, we're talking about many, many hundreds or many thousands. So the question was, how do we deal with this? How do we need to make any changes to our manageability tools? Or do we need to make changes to how we deploy and how we update these machines? So that was a biggie, I'd say. And lastly, monitoring. Well, again, everything, all the monitoring infrastructure is back in Skype DC. We have a couple of data centers in Europe where we keep majority of our stuff deployed. And if we need to deploy to Azure, like how are we going to connect Azure with our monitoring infrastructure? Do we need to deploy new monitoring to Azure, or how do we solve this problem? So that's that was a really interesting concern. So now, before I go into relays, we need to touch on one other interesting aspect of what we do in service engineering. This will be the story about health check and why it's important. So if you have done anything with an application or service that sits behind a load balancer, then you know that load balancer is used to distribute the load from your clients across your instances. But another important thing that the load balancer does is, of course, it will check on the instances that have failed, and it will remove them from the load balancing pool. Now, this is all fine, but in some cases, depending on what is your workload and what is your application, it could happen so that your application will only be removed from the load balancing pool once it's completely down. And of course, you don't want that, because normally every application has a limit at which it stops performing as well. So sometimes it's referred to as the knee point of an application in scalability, which means that basically your application scales linearly up to a point, and then it either flatlines or perhaps the performance will actually decrease. So what we want to do at Skype is we want to catch this point. We want to make sure that we will offload our application before this point is reached, because otherwise we risk that the quality of the call could suffer. So this is why in service engineering, we have done a thing called health check. Health check actually looks at different KPIs for the service, such as, I don't know, let's say the CPU load, the packet rate, stuff like that. But most importantly, it looks at latency, because in performance, the most important thing of all is latency. And we are specifically looking at UDP packet handling time latency. And we know at what, let's say, threshold we need to offload the instance. So this all is important in the story later on. So, and the last thing about these relays is we use DNS-based load balancing, which means that when the client tries to find a relay, it will do a DNS query, and it will be directed to the closest available healthy relay. So that's the health check. And I think it's pretty important in this story and actually in service performance in general. Now, once we have decided that, all right, let's try to make relays work in Azure, we had to do some load testing. Now, because we had the health check, it was actually pretty easy. Our job really was just to try different SKUs on Azure and see where will we get the best price performance for them. And so we ended up actually choosing a standard D4 as our SKU, and we went on from there. We did some experiments with production traffic for a while, just to ensure that the service runs stably enough. And once we were happy, we went actually further. Biggest question that we needed to I guess, answer in this load testing phase will how many such VMs will we need and in what regions. And we ended up coming up with a number around 1K distributed across 3 regions. So the next important thing when it comes to relays is the deployment model. And I would actually argue that this was the most, let's say, interesting part of the whole process of this whole first trial with our service in Azure IaaS. And really, up until now, majority of our services that we do in Azure IaaS reuse the same model in one way or the other. So what is the deployment model? Well, it's basically just a concept of having separation between your production machines and management machines. So what this means is in every region where we deployed relays, we also deployed a separate network that contained management machines. Management machines were distributed across separate failure domains and update domains, and they were separated with an ACL from the actual production machines. Then, once we knew that this is the way how we want to go, we had a really interesting problem to solve. How do we do connectivity from Skype data center to Azure. Now, back then, there were several options in Azure, several VPNs, several types of VPNs that we could use. But this all looked kind of complicated, and we thought, why not to try something easier? So we've been using TLS Tunnels for many, many years. This is a very simple solution, and if you set up enough redundancy, it works fairly well. So as long as you don't need to shuffle back and forth large amounts of data, like, I mean, gigabytes and gigabytes all over, then the TLS tunnels actually work really well. And so what we ended up doing is on every management machine, in every management network, we set up a TLS tunnel back to Skype DC. And we had 2 such tunnels per management machine because we have 2 main Skype data centers in Europe. And then what are the roles of the management machine? Well, as you probably have guessed by now, we use it as a jump box to jump into production, but it's also used as a proxy. And proxy for logs and telemetry, because all of our centralized infrastructure is in Skype, we really need to get that stuff back there for aggregation and alerting. Last thing we use management machines for is apt repository, because we run on Debian Linux. It sort of makes sense to have apt repos very close to actual production machines to enable really fast deployments of whatever we need to deploy there. So that's the deployment model. Now comes the sort of interesting part, and the part where I share a not so pretty graph, but it is real. It is a real graph from production, and it shows how we actually migrated our relays from Microsoft data centers and Skype data centers to Azure IaaS. So once we knew what the deployment model is going to look like, and once we knew the results of the load testing, and we knew how many VMs we need and in what regions we're going to deploy them, then it really was just a matter of doing the actual work and deploying them. Back then, we used Azure Classic as our tool for deployment because ARM, or Azure Resource Manager, was lacking some of the features that we needed. So what this graph shows is that around October 2015, we started deployment of Azure relays, and we did it in such a way that we still kept the Skype DC servers running, but in our DNS-based load balancer, we started adding Azure endpoints to it. And you see there's like a drop and then a new spike. These are our experiments with call quality. At that time, the demands for relays were growing rapidly, and we were experimenting to see how much bandwidth can we actually afford to give to each call. So there are some ongoing experiments there. Once we were fairly satisfied with the performance of Azure relays, we started decreasing the percentage of traffic that is sent to Skype DC, and so naturally, a majority of the traffic went to Azure. And as you can see, the traffic stayed in Skype DC as well for a while. And there's an interesting reason for that is during the peak times, we actually did not have enough capacity in Azure to service all the traffic. And so since we had the health check, once the Azure machines got overloaded, the remaining traffic was sent back to Skype DC. And so we ran in such a hybrid setup for quite some time. I would say some 3-4 months before we started actually actively decommissioning the Skype DC servers, and we switched to Azure exclusively. So in the graph, we see that the light colors are Azure, and the darker colors are actually Skype DC. So towards the end, it's all mostly in Azure. And then came our first problem. So we were so excited about Azure, and it all worked so well until this point when we realized that, well, even though it's mostly stable, there are reboots from time to time. Like for whatever reason, maybe the hypervisor reboots, maybe Azure is doing some maintenance or whatever. And this wasn't so great for us because relays are stateful, which means the clients who are connected to the relays, they expect that the relay is not going anywhere, at least for a while, at least during the call, right? But sometimes it happens so that the relay actually disappeared. And what this means for a client is that client must very quickly reconnect to another relay. So this is done actually transparently. The client will not notice it, but what the client can notice is a short decrease in call quality for the duration while the reconnection is happening. So obviously we had to fix this. And what we came up with is, luckily, there was a service in Azure called Azure Metadata Service, which is essentially an endpoint that you can query, even with curl. And what you can get from there is a bunch of information about your machine, like what region it's deployed, what's the size, and so on. But most important for us, you can get a flag which shows you that your machine is about to undergo maintenance. And Azure sets this flag 10 to 15 minutes before the reboot or maintenance is about to happen. What it allowed us to do is, now again, since we have the health check, right, then we were able to simply add an extra step into the health check so that health check script would not only query the status of the machine, the latency, but it would also query these endpoints and see if there is a flag set, the machine is about to be rebooted, then the machine is offloaded from our load balancer, and the traffic is drained, and no one ever actually knows that anything happened there. So that was a really nice solution, and we still use it till this day. And in fact, we use it with every other service that we do in Azure. Now, the really sort of internal success story was India. So in 2015, we were actively thinking about how to expand to India, because obviously we have quite a lot of clients there. And unfortunately, until end of 2015, we had to send them to some more distant relays in other regions. So as luck would have it, in September 2015, Azure announced availability of India region, and we immediately knew that we must use it, like no other way. We must use it, like how do we do it? Who do we need approvals from to get it done, and so on. So in December, we had our first relays running, and this was not due to any technical difficulties. This was mostly internal politics that required us to do some approvals and so on to get them set up. And really, this was I'd say, the beautiful part of this whole project, because it was so easy to set them up. We already had the deployment model. We had the automation. We knew how many we're going to need. So really, it was just running a bunch of commands, and that's it. We have India up and running. Once we were done with this project, to give you some sense of scale, we had around 1.2K VMs running on Linux in 8 different Azure regions, and we were doing around 40 gigabits per second of traffic. So not too huge, but also not that small, I'd say. And that's the story about relays, and that's the story about how we moved the service from running on bare metal machines to running in Azure IaaS. Now, to give some sort of information about what we do currently with Linux in Azure, I have some more slides for you. So, present day Azure IaaS at Skype. Well, like I said, we've been doing this for 3 years now, or a little bit more. And we've moved some services in similar fashion as relays, but we also are doing some new ones in Azure. I must say that we are quite happy, both with the performance and stability and the features as well. I will be honest though, and there have been some issues with Azure. We've seen quite a few. Most have been resolved, and most have to do with either network or storage performance. And there are 2 reasons why we see them. One of the reasons is that maybe sometimes something happens in Azure, some underlying performance bug or some platform-specific issue, and these are usually resolved fairly quickly. And then there are some more complicated ones. So Skype workloads are rather unorthodox sometimes, and the way how we use TCP/IP is a little bit different maybe how the usual microservices do it. So we've had some times where we hit some undocumented limits in Azure, and then we simply see that, wow, I mean, this is a no-go. We cannot do this service in Azure because it's just simply technically not possible. And luckily for us, Azure has been fairly responsive and actually has fixed these issues. So currently, I can actually honestly report that all the issues that we've had with Azure have been mitigated by now. Some of them are fixed completely. Some of them are still being fixed. So the story here is that if you see a problem, you can actually report it to Azure support. They will actually fix it, but it might take a little bit of time and patience on your side. So that's really good. How do we deploy our services? This is sort of learnings that we've had in the last 3 years. Well, nowadays, ARM is the way to go. Really, you don't want to probably use Azure Classic. It has several limiting factors there and several things that you need to do manually. ARM is a rather elegant solution. You simply describe how your environment is going to look like, and Azure actually takes care of everything. And the best part about deploying with ARM is the fact that you can describe the amount of machines you need, and later on, if you need to add an extra 10, 20, 50, 100, you just change one integer, redeploy, that's it, it's done for you. So that's really wonderful. We mostly use PowerShell to actually orchestrate the deployments, not because we have to, but simply because we're used to it. And this works fairly well for us. But lately, we are actually big fans of Azure CLI 2.0. And why? Well, mostly because it's written in Python. And we in Skype are huge fans of Python. We write our scripts in Python. The health check is written in Python. So, why this CLI 2.0 is good is you can actually import it as a Python module. And if you import it as a Python module, then you don't need to call any external commands from the shell. You simply call functions. So, I mean, it doesn't get much more beautiful than that. We actually use CLI 2.0 in one of the systems that we've built for automated image building. Because in this system, one of the steps is to deploy the image to Azure to test that it boots, test that it works, and then report back the results. So this is my attempt at trying to show you the manageability design. Well, really, it's rather simple. I thought of just having some text on the slides, but I thought maybe an image paints a better picture. The main point to see here is that really there are several data centers that we have in Skype, and we simply connect them via redundant tunnels over the internet to our management machines. And the important thing is that there are ACLs, both in front of management infrastructure and between your production and management layers. So, like I said, this manageability approach has been working really well for us. And this is something we are probably going to use time and time again. Now, another important learning in our sort of journey of Azure was building our own VM images. So if you are a fairly big organization, you have probably thought about it already, or you are doing it already. And there are many good reasons for that. So one of the reasons is maybe that you want to pre-bake your application into the image. So for example, if you want to spin off, I don't know, let's say 100 new VMs, you simply spin them up using this image, and it's all going to work for you. Or maybe it's a compliance reason. For example, in Skype Service Engineering, one of the things we are doing is we are also ensuring that our operating systems are compliant with all the requirements in Microsoft. And it's very easy to do if you have built your own image. When we just started, we were using HashiCorp's Packer to build the images. And this worked fairly well. It was easy to set up. But as time went by, we started using more and more Hyper-V in our own data centers. And we realized that we probably need a sort of our own system to build the images. Because we do fair amount of customizations in our images. We have optional full disk encryption. We have many other tweaks to the operating system and to the performance. So this system of building our own images was a decision we don't regret, and it has worked wonders for us. One thing, for example, it allows you to do in general, if you have your own images, is if, of course, they are built nightly. If you want to spin up new VMs, your normal cycle might be that you spin up the VMs, you do all the patching and updating, then you deploy your application, then you configure your application, then it registers with the load balancer, and so on. If you have your own image, you spin it up, you query the meta information from metadata service, you discover where is the machine deployed, and that's pretty much it. The last step remaining is to register it with the load balancer. So really highly recommended to cook your own images. Some other useful practices, well, perhaps worth mentioning, deprovision standby VMs. So not sure how cool this sounds, definitely not as cool as just using API to create new VMs, but actually rather practical. With some of the services, it's hard to predict how much capacity exactly do you need. And sometimes the provisioning steps still take minutes, maybe 10 minutes, maybe 15 minutes, and this might not be good enough for you. So what Azure allows you to do is it allows you to deprovision the VMs, so you don't pay for the compute. And if you need to, you simply provision the VM back, and it's up and running within minutes. So that's really good, and something that we use to ensure that there is some buffer of capacity at any time. Obviously, take advantage of failure domains and update domains. No reason not to do it. We've been doing it for these last 3 years, and really, we haven't seen any problems. So long as you have your infrastructure split across these update domains and failure domains, Azure is fairly stable, and really no reason to worry about that. Sometimes machines go down, and there's not much you can do about that. And I don't know how your monitoring looks like, but sometimes we're not too proud about ours. And in some cases, if a bunch of machines go down, then you can get lots of, like a flood of alerts coming in. And if this is like middle of the night, you are the on-call person, so you're probably not too happy about it. And the first order of business is to understand what is going on. And in order to do that, we have a check for reboot velocity. What it basically means is simply we are checking the uptime of the machines, and the moment we detect that the uptime has massively decreased on a large amount of machines, we fire this alert off. Now, what this does is it's really simple, but the on-call, when he or she wakes up, then they can immediately see, wow, the reboot velocity alert has been triggered, so something is really wrong in Azure, so let's offload the whole region instead of trying to debug the problem, because it's probably not related to our application itself. Luckily, we've only had situations like that a couple of times in the last 3 years, but it can happen, it probably will happen, this is inevitable, so you should prepare for that. Detecting hypervisor change is a little neat trick that we're doing. You can easily do that on Azure VMs, and what it really gives you is, in case you notice any strange things in monitoring, let's say some gaps or dips in your graphs, then, and you don't see any explanation for that, if you have detected that the hypervisor has changed, then you can actually deduce that the Azure platform has migrated you from one hypervisor to another. So it probably doesn't affect you too much, but it allows you to explain some weird things on the graphs. Metadata service really, if this is the only thing you take from this presentation, start using metadata service. It's really a life changer, and especially nowadays when they're adding more features that allow you to detect in which region you are deployed to, then this is really valuable. Now, I must say that for the actual orchestration of applications and for deploying the actual software, we do use Ansible heavily. We've used it since forever, basically, and we keep using it in Azure as well. The beautiful part about using Ansible is that regardless if this is a new location where you're deploying to, or if it's an existing one, you have the same playbooks, the same roles, you simply run Ansible, and it does everything for you. It does not depend on any management infrastructure or anything else for that matter. So, really valuable tool for that. A local firewall is a good thing to have as well. In Azure, at this moment, unfortunately, there is no way to ensure that the ACLs that are defined are actually there. So, probably and hopefully, it's there, but hope is sort of not a strategy. So the best thing to do is to apply local firewall as well, and then you have the peace of mind that that only the services that you expect to be running on the internet are available on the internet. Lastly, resource locks. So I'm pretty sure that most people have heard about these tragic moments in developer or engineer lives when they are doing a deployment to QA or test, to do, I don't know, some smoke tests or whatever, and they realize that, hey, they are deploying to production instead, and during this deployment, they wipe out all of production. So we, luckily, as far as I know, haven't had such issues in Skype yet. Anyways, it's always better to learn from somebody else's mistakes. And in order to avoid this, it's very easy. You set resource locks in Azure. So any resource group can have a lock. The lock can be either lock that prevents you from deletion, or it can be a read-only lock, which means that you can still do this, but first you'll have to remove the lock. And what we do is everything is automated except the removal of the lock. So if anyone runs the automation, it will fail. And the removal of the lock is a separate step. So that's sort of it for the best practices. Last thing to note here is Azure really is growing fast. And in the last 3 years, we've seen plenty of new regions added. We've seen new V2 machines. And the V2 machines, again, if you're not using them yet, start using them. They're actually faster and cheaper than the previous ones. And I guess one last bit of advice, the GitHub account of Azure and all of Microsoft is actually a really good place to see what's going on. We have had several cases during developing of our ARM scripts for automation that we see, where is this error coming from? And we go on the GitHub and we see, all right, there's an issue already. Perhaps we can add some more detail to this issue, or perhaps we can simply learn from it. Either way, it's a really good thing to check and, I guess, be tracking. So that's all from me. I'm Kaspars from Skype. If you have any questions, we'll have someone who can answer them as well. So thank you.